When students are learning to add and subtract fractions, they often spend a lot of time and effort trying to figure out what the least common denominator is. You actually don't need to necessarily find the least common denominator to add or subtract fractions. You just need to find a common denominator. And the easiest way to get a common denominator for two fractions is to multiply the top and bottom of the first fraction by whatever's on the bottom of the second fraction, and to multiply the top and bottom of the second fraction by whatever's on the bottom of the first fraction. For example, for 2/9 plus 7/15, I'm not going to take my time to figure out what the least common denominator is. I'm just going to go ahead and multiply the top and bottom of my first fraction by 15 and multiply the top and bottom of my second fraction by 9. That's going to leave me with 15 times 9 as the denominator of my answer, which is 135. Then in the numerator, 15 times 2 is 30, 7 times 9 is 63, 30 plus 63, we have 93 over 135. Now we do need to see if we can reduce it. One thing both of these are both divisible by is 3. Divide them both by 3 in the numerator. 93 divided by 3 is 31. In the denominator, 135 divided by 3 is 45. And that would be our answer. Let's try something similar for 5 over 6x cubed minus 11 over 8x to the 5th. On the first one, I'm going to multiply the top and bottom by 8. The second one, I'm going to multiply the top and the bottom by 6. However, these also have x to the third and x to the 5th in the denominators. I can leave the x to the 5th where it is, the higher exponent, but x to the third I could turn into x to the 5th by multiplying by x squared. So I'm also going to multiply by x squared on the top and bottom of that first fraction. Doing all of this is going to give me, in the denominator of both fractions, 48 for 8 times 6, x squared times x cubed, we would have x to the 5th. Now in the numerator of the first one, x squared times 8 times 5, we have 40x squared, minus 11 times 6 is 66. Now when you have a fraction with 3 terms like this, to reduce it, you want to find something that all 3 terms are divisible by. In this case, all 3 terms are divisible by 2. So we divide them all by 2 and we'll be left with 20x squared minus 33 over 24x to the 5th. Let's take a look at the example, negative 2 over y minus 5y over y minus 3. Here, to get our common denominator, we're going to follow that process of multiplying the top and bottom of the first fraction by what we have on the bottom of the second fraction. In this case, we multiply them both by y minus 3. We multiply the top and bottom of the second fraction by what's on the bottom of the first fraction, which in this case is y. When we do that, our common denominator for our fractions will be y minus 3 times y. Note that it's better to leave it factored here. Instead of distributing the y and getting y squared minus 3y, it's going to be better to leave it factored as y minus 3 times y. The reasoning for that is later on, we're going to factor it to try to reduce it anyway, so it's better to leave it in a factored form. In our numerator, y times negative 2, we would have minus 2y. Negative 3 times negative 2, we would have plus 6. Now be careful with that next term. Notice it's not just 5y times y, we have a minus there in the middle. So we need to think of it as negative 5y times y which leaves us with minus 5y squared, like so. So if we work this out, or put it in descending order, I should say, we would have negative 5y squared minus 2y plus 6 in our numerator. In our denominator, we have y minus 3 times y, like so. Okay. Now, this one, it may not be immediately clear whether you could factor the numerator or not. It turns out that in this case, you're not able to factor the numerator, so we would leave it alone, and then there's nothing that we're able to do to reduce it. Okay. If you would like to try the next problem on your own, pause the video now and resume when you're ready to see the solution. For the next problem, we multiply the top and bottom of the first fraction by what's on the bottom of the second fraction, a plus 2. And we multiply the top and bottom of the second fraction by what we have on the bottom of the first fraction, a plus 5. This is going to give us a common denominator of a plus 2 times a plus 5. In our numerator, we're going to need to multiply and see if we have any like terms we can work out. 3a times a is 3a squared. 3a times minus 2, we would have minus 6a. Next, 4a squared times a, we have plus 4a to the third. 4a squared times 5, we have plus 20a squared. Combining the like terms and writing things in order, we would have 4a to the third plus 23a squared minus 6a in the numerator. In the denominator, we would have a plus 2 times a plus 5. Okay. All right, now in our numerator, we can do some factoring to see if we could reduce it. We can factor out an a, and we would have a times 4a squared plus 23a minus 6, leaving the denominator the same while we're trying to see how much we could factor the top part. And in this case, we actually could factor the top part a little bit more. We could have a 4a and an a, and then a minus 1 and a plus 6, like so. And then in the denominator, we still have a plus 2 times a plus 5. Now, it turns out, even after factoring, there's nothing we would have been able to do to reduce it. So that's it. That's our final answer.